record button and officially wish everyone a happy garbage day, or a Tuesday, whichever you prefer. Another windy garbage day, as it turns out. What I have in front of us is the agenda for the rest of the semester. We are really in the final countdown stage here. So we have homework 5 was submitted last night. Thanks to you, those of you who submitted that. If you haven't got it done yet, just a reminder, you can turn it in at any point until the end of the semester for 2 points off as a deduction. If you do want to revise it, those revisions will be due at the end of finals week. I posted a new example that we can talk about today, higher order factored models. So if you haven't grabbed those files, please do so. And then we have the grand finale of building to an actual structural equation model with predictors and outcomes and everything. And you might be asking yourself, why are we only doing this in the last week of the class? Because that's the easy part, is the answer. Once you have your measurement models built, connecting your latent factors with 2-headed arrows or 1-headed arrows is the easy part. There's a lot less that can go wrong at that stage. Extending these models into growth model kinds of things for longitudinal data is a whole nother story and a whole nother class. So I will put that caveat in there that I've deliberately stayed away from those sorts of content, but that does show up in the advanced longitudinal that I hope to bring back in a year from now. So we'll talk about SEM, we'll talk about some alternatives. That's the last week of classes. We also have your next formative assessment due on Monday, your very last one. And this one, I hope, will be a little more entertaining than the usual definitions. This one is based on a true story of me fighting with Reviewer 3 to get a manuscript published. So I'm going to put in literally the feedback that I was given, and I want you to try to make heads or tails of it. Because sometimes it's difficult to understand exactly what the complaint is. So that's going to be our formative assessment number 5, and I will take that one if it's. Vladimir said I think that was okay. I think Cass said that was okay. Maybe but since it's a true story and there's not really an answer key per se. And then finals week, no classes but office hours. So my deal with office hours is that I will be here at any point. I would normally be teaching or having office hours. So you'll have me for several hours each day, but not on Friday. And note that everything needs to be done by 5 o'clock on the very last end of finals week so that I can get grading done and get grades submitted. Homework 6 is the other last thing that you'll be working on. That I plan to release on Thursday. It's going to be an online assignment where you get to do measurement and variance using CFA and IFA models. So hooray! He's like, yay, I love tedious code. But it's a good skill. Being able to manipulate the code and keep track of all the different files is also sort of an unintended benefit of this, because some of you have spoken to me, you're already in file hell with all the different versions of M+ files floating around somewhere. Yeah, that's developing systems to keep track of that and make sure everything stays organized is a useful thing. So that's what we got. That's coming up still. Any questions? Stuff I'm forgetting? No, we're good? Okay, you want to talk about higher order factor models? Yeah, we do, don't we? You woke up this morning and thought, I can't wait to talk about higher order factor models. Here's a picture to remind you.
I actually, when I saw that this was the topic for today, I said, thank goodness, because this is what I need to finish the homework that was due last night. So I'm actually excited.
Yes, excellent. Well, I did not intend for homework 5 to turn into a higher order factor model since we hadn't talked about it yet, but I know that several of you have them, so or at least have them hypothesized, so it's a useful topic in that regard. So what are they for? Let me just ask you like a big picture question. I've got the slides up here to motivate us. What is the purpose of a higher order latent factor? Words, gestures, letters, anything that comes to mind. To account for factors having shared origin, yes. Comment in the chat to see whether your individual factors are part of a bigger factor, yeah. I would agree with both of those. More concretely, what is the higher order factor trying to recreate? The lower order factors try to recreate the covariances among the items. So what do the higher order factors do? Covariance among the factors, exactly right. It's the exact same concept, not consequence, concept, that's what I wanted, as the lower order measurement models. So at this stage though, each of these circles, the lower order factors, is a continuous variable. So the difference between IFA and IRT or CFA is moot at this point. Higher order factors are functionally like CFA models. The other thing is that the means, because we typically estimate intercepts per item or thresholds, the factor means are 0. They have no information that needs to be recreated by the higher order factor. So it's really just all about the higher order factor being able to predict the covariance among the factors. And if I only have 3 lower order factors, what can I do? Like in this picture. Can I fit this model? Is this identified? Yeah, so the overall model is over-identified because it will have a lot of degrees of freedom left, but the structural model is indeed just identified. So I can fit it, but I can't test it. That's the thing. Because an equivalent model is just, why don't you let the 3 factors be correlated? I can do that, or I can have 3 loadings. So how many lower order factors do I need to make this higher order factor testable? 4. And I'd go for 5 just in case, so that you have room to be wrong, right?
What if you don't have 5?
Well, then you better pray. That's you got to talk to some other higher power, higher order factor power. How's that? Whoever that's responsible for that in your life. But I do have an example that has 5 factors. This is example 8. And this is real, I should say this is a real data set, a former student project. I did not help with the analyses that developed the scale, but I did help the student evaluate the fit of the scale. And the topic of this is a little bit of a bummer. It's childhood maltreatment. The 5 factors are basically 5 different ways that parents can be mean to their kid. I know. These data come from a typical undergraduate psychology subject pool. So there's a whole lot of skewness here because fortunately most of the kids did not have a lot of bad things happen to them. So there's a lot of lower responses. So even though this is going to be a 5-point response scale, it is questionable whether CFA is a reasonable thing. So because of that, and because I wanted to show you examples of what it would look like across different kinds of measurement models, I'm going to go through the same process of testing the fit of a higher order factor. First, treating the measurement model for the items as CFA, so pretending that it's continuous, fitting a linear effect of the factor on the responses, and then go through the same thing with IFA, so we're treating them as ordinal. You will see that the process looks a whole lot the same. The only difference is using likelihood ratio tests given maximum likelihood estimation versus diff test given weighted least squares estimation. So the factors themselves are spurning, so verbal and nonverbal acts that reject and degrade a child, terrorizing, it's fairly self-explanatory, isolating, corrupting, and ignoring. So some of these are active ways of being mean, and some of them are more like neglect, like passive ways of letting bad stuff happen to your kid, and that distinction will matter as it turns out in looking at what happens. There are different numbers of items in these 5 subscales. They range from 12, actually no, 6 is the fewest all the way up to 15. Any guesses as to why they're uneven like that? Why some of these subscales have more items and some have fewer? Think cynically.
Because maybe with some of the factors that are more scary, you only need a few items to...
If a factor is more scary, you might need fewer items. That would make sense, but that's not the reason.
There are more ways to ignore a child than there are to, for example, corrupt or isolate one.
More ways to ignore someone than to corrupt or isolate? Possibly, but that's not the answer. Think cynically. Because they used exploratory factor analysis, and this is where it put them, is the answer. That's it.
You meant cynically from a researcher perspective, not from a data perspective.
Cynically from a researcher perspective, yes, I should be more clear. There's room for all different kinds of cynicism, but this is what happened. So in practice, I would not recommend this. I would try to have more balance in terms of the number of items, especially if you're interested in seeing how each of these different traits differentially predicts something else. Because the traits that are measured more poorly with less reliability, given fewer items, those may not relate to other things as strongly, and you wouldn't know if it's because of the thing that the trait is reflecting in terms of the construct or the way that it's being measured is inadequate. So in practice, I would try to make these a little more balanced, but this is what we got. So the first thing that I did within each CFA and IFA framework is make sure that each of these factors fit reasonably well. And some of them do and some of them don't. So this is another case in which I'm told the student, just go ahead. I know you need to finish this project and it's not your responsibility to make things fit. But on here, I have a summary of the fit indices of the CFA solution for each of these factors, as well as the WLSMV solution. And it does look like if I treat these items as ordinal, which they actually are, that fit looks a little bit better. So I will say that I'm not sure if that necessarily means anything, but this is what it appears. It looks like fit is better when you let the items be the way that they're supposed to be. RMSEA is not super happy with this in some cases, but CFI and TLI are. And then the models that we're going to go through are also summarized down here, and all associated M+ output files are in the download folder for you, the zip folder. And then Jonathan did a Lavon version of this many years ago that I linked to as well, so you can see what that would look like in the R framework. Here are the standardized loadings within each of the estimation/model options. So MLR is the CFA solution, WLSMV is the IFA solution. And you can see that most of these items look like they're contributing to the factors, so no giant red flags that would prevent me from going forward. Okay, so any questions about the story or the items or the setup so far? Okay. Then, what if you wanted to make a total score? That's consistent with the single factor model. So I'm calling this the straw man model because this is a point of comparison that would be of interest for anyone who wants to know, can I just add them up and make it one thing instead of 5 things? This is the model that is consistent with that, a congeneric model. However, I had already written out all the code and I didn't want to change it, so let me show you a trick to fit a 5-factor version of a 1-factor model. So in the data set here, I've got an ID variable and a whole bunch of items. They ended up not using all of the items in this analysis, and so I deliberately left the holes where you could see the ones that were missing. Also note one of the conventions that I do in my code is I put leading zeros in numbers that are less than 10. That way everything stays aligned. It's a lot easier to troubleshoot coding problems if you can clearly see where things are off. So I tend to do that. M+, of course, doesn't care what you call things, so P for, I don't forget why. It's just P. We have, let's see here, MLR estimation. Don't need to save factor scores or make pictures for this, but if you wanted to, here's some code for that. So I have a standardized factor method of identification going here. So each first item's loading is being estimated along with all of the others. That means that I have to fix the factor variances to 1. So I did that down here. I fixed all the factor means to 0. What is not included in the code are 2 other things about the measurement model. What did I not write? I've got the factor loadings, but what else am I not writing in terms of the code for a CFA? What other measurement model parameters am I going to be estimating besides loadings? Zoomers can play along too, watching the chat. Error variances is one. Intercepts is the other, yes. Got it near simultaneously. I didn't write those because I don't have to. Those are always going to be estimated by default. Every outcome automatically gets an intercept and automatically gets a residual variance, so you don't have to do anything for that. In previous examples, I had written out everything so that you could see how to reference all the parameters, but at this point, I feel like we don't really need to go there. We'll focus on the factor structure. So here is how I tricked this 5-factor model into becoming a 1-factor model. Because all the variances are 1, that means that the relationships among the factors that are directly estimated as covariances are already in a correlation metric. So another way to say that I have a single factor model is that all 5 factors are perfectly correlated. So rather than rewrite my code to explicitly say I have a single factor, I kept the code the way it was, and I fixed all of the possible factor intercorrelations to 1. So I am creating a single factor model by doing it this way, just to see how badly it fits. Because of that constraint, M+ gives me a nice ugly warning message. The latent variable covariance matrix psi is not positive definite. What does not positive definite mean in layman's terms? Broken. Yes, so normally if you see this, it's like ruh-roh raggy, but it broke because of me. It's broken because I fixed all the correlations to 1, which puts them on the boundary of what they should be. So this is an error message that I feel comfortable ignoring because I'm the one who caused it. So here's my HO model, scaling correction factor. Look how big that is. So that's another indicator that these are not multivariate normal items. The rest of the fit, RMSEA is reasonably happy with me. Still significantly greater than 0.05, but within what most people would call acceptable. That's because this is a relatively parsimonious model. I have 1,127 degrees of freedom left over. That's a lot. Where that number came from is down here. So the number of free parameters that's possible is 147, that's how many we spent, excuse me. And that is 49 loadings, because I have 49 items, 49 intercepts, 49 error variances, no structural model parameters at this point. So that's where I end up with this 1127 left over. It is after the 147 parameters I had to estimate for my 49 item measurement model. And because this is CFA, it runs really fast, even though it has this many items and this many factors in it. CFI and TLI are definitely not happy with this model. SRMR is like, it's fine. So not a lot of evidence so far for 1 factor. Let's see what 5 factors looks like, since that's what we thought it should be in the first place. So still keeping the same method of identification, where I have a standardized factor, z-score metric of variance 1, mean 0 for those. And now I have dropped the constraint of at 1 that forced all the correlations to be 1, and now they're going to be estimated. So another way of thinking about this is, to what extent are the interfactor correlations less than 1? That means that I have multiple factors rather than 1. So several of you in your homeworks ended up with the 2-factor model. How correlated the factors are is also evidence for that. So it's not just that the 2-factor fits significantly better, but is it a correlation of 0.7 or is it a correlation of 0.95? Right? Like if it's 0.7, I'm like, yeah, it's really 2 factors. If it's 0.95, it's like, yes, it fit better, but functionally speaking, these are the same thing, and that might be a candidate for some kind of higher order combination for 2 that are that highly correlated, for instance. But in our case, we are interested in the relationships among these 5 things and whether or not they look like they could be consistent with the idea of 1 common higher order factor. So model fit, RMSEA is happy now. It's 0.047. CFI and TLI are happier, it looks like. SRMR is happier. I did a likelihood ratio test against the previous model where I fixed all 10 factor correlations to 1, so that's where the 10 degrees of freedom came from, and it's decidedly happier with this model. And here are the latent factor correlations. I got these, by the way, out of a new piece of output. I think I forgot to say this. Yeah, Tech 4. So in M+, there's a bunch of different extra pieces of output that you can ask that start with tech for technical something. I think it goes up to 20, maybe. Tech 1 is for troubleshooting. Tech 4 is latent variable correlations. Tech 8 is when you do Bayesian stuff. And then I think most of the higher order ones are for mixture models, if memory serves. But those are the ones that I have memorized that I use periodically. So this will print a correlation matrix of your latent variable correlations, which is what I stole and then threw into Excel to make it color-coded. So what do you think about this? Do these factors have something in common? Let's start there. Yes, so it's not game over, right? Like if the factor correlations were 0, there would be no point in testing a higher order factor because there would be nothing for it to recreate with its variance. Now, does it look unidimensional? You say no? Okay, what makes you say no? This is just a thought question at this point.
Well, certain covariances are greater than others.
Yeah, these are technically correlations, but they're the same thing in this case because the factor variances are 1, but yeah, some of them look stronger than others.
Yes, like Spern and Corrupt is a lot
Yeah,
different
so-
from Spern and Terra.
Yeah, spurn and corrupt is on the lower side. Spurning and terrorizing is very, very highly related to each other. Isolating and spurning. Corrupting and ignoring is a low relationship, which sort of makes sense, right? Because one is like passively being mean and other is actively. Corrupting has items like gave your kid beer, gave your kid weed, that kind of stuff. So I guess being a cool parent in some cases, cause for social services to come check on you and others, perhaps. Yeah, Hugh, if you're ever listening to this, I am not going to be the cool mom who gives you beer. It's not happening, okay? It's just not. I'm not of that kind. All right. No, I was the kid in high school who drove their friends home when they were drunk and then I missed my curfew and got in trouble. But I thought, well, I can live with that. I could not live with myself if my friends got hurt on my watch. So I'm going to be the not cool mom who takes care of their kid. So yeah, these look a little heterogeneous, but we know that there's at least something here. So the question is whether or not a single higher order factor can recreate these correlations. That's what we want to know. So from that perspective, this is our new saturated model answer key. Like this is as good as a structural model you can get. Everything is being estimated that can be. So the factor variances are fixed to 1 for identification, the means are fixed to 0 for identification, and then this is the story that we're after right here. So to ask the question, are these correlations consistent with the higher order factor, I'm asking, can I fit 5 loadings instead of 10 correlations and have the model fit? Am I going for worse or better? Worse, not worse, or better, not better? Which is this? If I start with 10 correlations and I ask if they can be recreated with 5 loadings. Not worse is what I want, not worse, in terms of absolute fit. Now, RMSEA, for instance, might like it better because it's a more parsimonious model, but in terms of absolute fit, I'm going for not worse. Question?
Yes, sorry, Lisa, but there you have covariances, right?
These are the covariances among the latent variables, but they're in a correlation metric here.
Oh, okay, great.
Yep. And by the way, I threw up the Excel sheet that I pasted all this stuff into, so you can see sort of the process. More questions? Yes, please.
So if we are using MLR now, what's the reference? The variance covariance metrics or the correlation metrics for the MLR method?
I'm not sure I understand the question.
Yeah, so here for maximum likelihood, what's the reference metrics? The variance covariance metrics or the correlation metrics?
Okay, so the answer is the same regardless of estimator. The original unstandardized parameters are trying to reproduce the means, variances, and covariances of the items. The unstandardized parameters of the higher order structural model are trying to reproduce the factor variances and covariances. The standardized solution is responsible for the correlations among the items or among the factors.
Great.
So it's a difference in scale, but they do functionally the same thing.
Good.
Yeah. So with respect to the fit of the structural model, this correlated 5-factor model is as good as it gets. So here's how we test whether those factor correlations are consistent with the idea of a single higher order factor. Step 1 is changing my method of identification. So this is the first time you will have seen this this semester. The marker item method, as your textbook calls it, where the first item's loading is fixed to 1, in each of my factors. A quick review question, what if I wanted item 29 to be my marker item instead? Could I do that? Would it fit any differently? Nope. The only difference would be that the first factor's variance would become the part of item 29's variance that's due to the factor, like the good part, the true part. Whereas in the original version of this, it would be scaled with respect to item 6 variance that's due to the factor would become the factor variance. So the first item, there's nothing special about it. However, what is the one exception to this rule? When would it matter what marker item I pick, which one I pick? There's one situation, and I have seen it in practice the first time I taught this class. Way back in 2007. What's the one situation in which it matters which marker item you pick? What if you pick a bad one? That happened to my student. She was fitting models and they wouldn't converge. And I looked at her code and I'm like, there is nothing wrong with this. I checked the data, everything looked fine. On a whim, I'm like, why don't you try a different marker item? And it worked. Lo and behold, her first item had a 0 factor loading when the model was estimated. It had no variance to pass up to the factor, so the factor variance was 0, and it did not like that. So that was what happened. So don't pick a bad item, is your take-home message on that one. Pick an item that's related to the factor and you'll be fine. It's not going to change how it fits or what the model predicts. Now, why did I do this? Why did I change my method of identification given my intention of fitting a higher order factor? We talked about this last time, so this will be a little bit of review. There. Why did I need to do it
Because you want
this
to
way?
be able to estimate the variance for the factors themselves, so you have to have something else fixed.
Yes, I have to be able to estimate the factor variances so that they can become factor variance left over. So in the same way that once an item is predicted by the factor, we estimate its error variance specifically, the part that's not the factor. Same exact principle here, but with a new vocabulary word. What is factor variance left over called? And feel free to read from the screen, as always. Disturbances, yes, there's a disturbance in the force. So these are the idea of factor variances left over, because after I set up my measurement model and estimate my factor variances, note that my factor means are still fixed to 0 because I'm estimating all of the intercepts for my 49 items. They become factor variance left over based on this set of commands at the end. So I have a new factor that I'm defining. I called it abuse because it's 5 letters and it seemed to fit. And it is indicated by spurning, terrorizing, isolating, corrupting, and ignoring, as if they were items. It's the exact same logic. The only catch is order of operations. I'm pretty sure M+ will yell at you if you put like this part first, but it doesn't know what spurn is yet. So you would want to define your measurement models with your items first, and then refer to those latent factors as indicators of the higher order factor model. And I am using a standardized method of identification for that higher order factor in which its variance is fixed to 1, its mean is fixed to 0, and that way all the loadings can be estimated for the 5. Question?
So in M+, does it matter the number of items you, like, is there a higher boundary as to the number of items you can have?
In an
for a
analysis?
factor,
Or
for lower order factor? Just like running it. Like,
question?
I see here you have 12 items for spurn.
Yeah, one of them has 15. Ignoring is the biggest one.
Oh, ignoring,
Yeah.
So it doesn't matter how many?
It doesn't matter. I think at some point it becomes a computational issue, like how long it's going to take the model to figure out what all the parameters are, but I don't know that there's an upper limit in terms of what the software can do. I'm not aware of one. I know that if you try to get the like the test version of M+, they have like a trial version that is limited to like very few variables in very few cases on purpose because they don't want you using that. So. Okay, so this isn't bad, right? You know how to do this? You had the power all along. It's like the Wizard of Oz. So what do we think here? Let's go over to the fit side of the story. Chi-square, wildly significant, not surprising. I don't forget how big this sample is. What did I say? Did I tell you about that? Oh, 1,336. So that's not considered super huge in SEM, but it's huge by my standards, where I'm used to helping people with like 20 cases, right, Eric? How well does IRT go if you have 20 cases? It does not go well. Yeah. Yes, those of you who work with longitudinal data or special populations will appreciate this idea that a large sample is entirely relative to your research base and your availability of being able to get subjects. Okay, so chi-square, wildly significant, not surprising. RMSEA is happy. CFI and TLI are not that happy, but they weren't happy before. SRMR is happy. So I'm going to say, look, it's consistent with the higher order factor model. I win. What do you say to that? Because I've seen this in the literature quite a bit. Based on the overall model fit, people will try to make an argument that a higher order factor fits their lower order factors.
You have to compare it to a model where you don't have a higher order?
I do need to compare it to a model without a higher order factor, because most of the degrees of freedom that are left over are because of the measurement models. What I need to know is whether the 10-factor correlations are adequately recreated by my 5 loadings. That's what I need to know. That's a nested model comparison. Survey says, which by the way is a game show reference, this is not an actual survey. So I'm quoting Family Feud because whenever they put the answers up on the board, that's what they say. Survey says 5 degrees of freedom. That came from 10 correlations versus 5 higher order factor loadings. Significant, so yeah, doesn't look like it fits yet. Here are the higher order factor loadings though from this solution. So all of these are pretty strong. Corrupting is the lowest one, which makes sense because of the way that it's measured by its items. It's a little bit different of an animal. So how do I fix it? When we look at local misfit via residual matrices, discrepancy matrices, as well as modification indices, I have isolated just the things that would be relevant to trying to make the higher order model fit better. So I'm ignoring everything else that it said with respect to the items. And it wants some with statements. What are these? What does it want me to do? Covariance. So these are like error covariances for items, but they're disturbance covariances for factors now. So the part of corrupting that is left over after being predicted by the general factor of abuse wants to have an extra relationship with the part of terrorizing that is left over after being predicted by general abuse. And the same is true for ignoring with terrorizing. So once you put any of these into the model, the rest of them will all change. So normally you would want to do this sort of in a stepwise fashion. I went ahead and added them both at once because I knew what was coming and I already have a 12-page handout. But here is the information that we would need to be able to figure out what this is, why these suggestions are being made. So the top matrix, this color, this is the original. So this is the right answer. This is the 5-factor correlated solution. These are the correlations among the factors. The one below it, I got out of the residual output as what the model predicts. So based on those higher order factor loadings, this is the correlation matrix that the higher order factor model is predicting among the factors themselves. So we can do the same thing of looking at local misfit at the structural level. I computed literally the discrepancy. So for instance, 0.929 is what this correlation was in the 5-factor correlated model. It was predicted to be 0.925 in this one, so it's off by 0.004. So the two that are the most off relative to the others are the two that the modification indices are saying we should fix. Not a coincidence. That's what they're reacting to. misprediction with respect to the factor correlations. Not
I
too
have
bad
a
though.
question.
Yeah, hit me.
So for ignore and terror, the leftover part, like it's like negative, right? And doesn't that mean that they want to be less related?
Yes, it does. So yes,
So then
direction
why
matters.
are we adding a with statement? Because that seems like that creates additional things instead of like taking away the relationship.
The modification indices for that one actually agree with you. It wants a negative disturbance relationship between those two. So yeah, there's something about them that is opposite after controlling for abuse, which makes sense because ignoring is passive and terrorizing is active. So they are somewhat inverse. So there are situations in which a negative relationship would make sense to add, and I would argue that this is one of them. But yes, you're right, they are less related than what the model predicts. So the disturbance relationship would reduce their expected correlation accordingly by making it negative, by taking it down. So guess how I fixed it? Here's your answer. Do what it says and add a semicolon. So the new disturbance relationships are down here at the end. 2 new lines of code. So corrupting with terrorizing, ignoring with terrorizing. Here is the new predicted matrix, and here's the new discrepancies. So most of these correlations now are predicted adequately to like the second decimal place at least. Pretty good. So in the new model, here are the results we care about. Higher order factor loadings are still nice and high, except for corrupting being the lowest one. And now we have a positive relationship of corrupting and terrorizing after controlling for abuse, a negative relationship of ignoring with terrorizing after controlling with abuse. So how do I know if this is good enough? What do I compare back to? These are both significant individually, so that helps. But if I want to answer the question, now is my model consistent with the higher order factor model? The previous model, that would be one way. So relative to the previous model, do you mean the higher order factor model without these relationships? Yes. Then I added 2 new relationships, right? Is my model fit going to get better or worse? Which way am I going now if I compare back to this higher order factor without these things? This is then the better direction, right? Because we're missing these. So that's one thing I can do is, did this help? Yes, it did. Hooray. And is it good enough yet? Good enough yet, what do I compare back to? Not quite the straw man. Saturated. Not the single factor model, but the 5-factor with the correlations, because that's my answer key as to what the correlation should be. So that comparison now has only 3 degrees of freedom, because I had 5 higher order factor loadings and 2 additional disturbance covariances to reproduce the 10-factor correlations. So I'm only saving 3, but at this point, the significance test says, yes, you are there yet, congratulations. You now have a higher order factor, but with like an asterisk at the end of it, because it's higher order plus 2 more things. So does this mean that we can add up these items and make a total score? What do you think? No, it doesn't. A total score does not have the middle layers of factors in them. So a total score would say that all of the items should have the same expected correlation regardless of what kind of item they are, whereas this model that has a higher order factor builds in additional relationships of the items that are part of the same lower order factor. Also, adding things up is what kind of measurement model, Erica? I'm going to call on you specifically. Parallel items model. She gave a ProSem presentation all about it, so you're never going to forget that. And what's a parallel items model?
Testing,
Yep.
it has the equal loadings and the equal error covariance.
Yeah, equal loadings and equal residual variances in this case. Yep. So that's not what we did here. This is a congeneric factor model where each item gets its own loading. We're not trying to say they're equally discriminating, nor do I think that would be a reasonable question to ask in this case. So no. The answer is no, you cannot add this up and make a total score. But you can have a higher order factor predict stuff. And that's the point of SEM, is to not have to make observed scores, to let the variables stay latent and then look at all the ways that being mean to your children affects their downstream consequences. Or yours, right? Maybe this is an analysis about the parents, who knows? But the higher order factor would be the latent variable analog to the total score. There. Okay. How are we doing? It's not bad, right? Those of you who have higher order factors, you're like, is that all? Is that it? It's kind of anticlimactic, huh? How about we do it with WLSMV? Because we can. Why am I using limited information estimation in this case? 2 reasons. I got 5 factors and I'm about to add a 6th. How many quadrature points would that be? Too damn many is the answer. 15 to the power of 6. That's not going to go well. Also, it's easier to check overall fit with a limited information estimator. The one drawback to this that you should remember, why is this less than ideal relative to full information in one respect? Missing data, yeah, this assumes missing completely at random. So if that's not the case, then you should be concerned about this approach. Potentially multiple imputation or some kind of Bayesian thing where it's iterating across, filling in the values and re-estimating the model would probably be better choices. There's not a lot of missing data in this analysis though. So since we're switching to an ordinal model, the code switches accordingly. Categorical is our magical statement here that tells it to figure out how many categories and estimate that number of categories minus 1 as submodels. We're changing the estimation. Parameterization equals theta refers to having the residual variances be 1. That corresponds to a probit scaling. The alternative is delta, in which the total variance is 1 instead. And because I know what I'm going to be fitting after this, I'm saving it. So this is where we do model comparisons using DiffTest instead. So this is my initial, what do we got here? 5-factor model? Yes, there it is. So this part of the code is exactly the same as the CFA model. All I'm defining is the relationship between the lower order factors and their indicators, and then allowing all the factors to be correlated. So this is the 5-factor correlated model. The code is identical on the right side here as to what we did for CFA. Now, how well does M+ like it? RMSEA is meh. CFI and TLI are happier with this version of the model, though. And our SRMR looks to be okay as well. Can I fit a single factor instead? Doing the same trick where I fix all the factor correlations to 1 to create a single factor model. And then put the 5-factor model in to compare against under the analysis. So just to remind you, the first model you fit, DiffTest goes on save data. That's the larger model. Then the second model is nested within it, the smaller model, in which that same command would go on the analysis command instead. So it's bringing in the information from the 5-factor model to compare against the 1-factor model. Survey says, what do I look at to know whether or not I have 5 factors or 1 factor? Weird saw noises coming from our ceiling. Yeah, chi-square test for difference testing. I did not make that up. That's what it's called. So there's two chi-squares here. The first one is testing whether or not the model overall recreates in WLSMV ordinal, what are we recreating?
The covariances of those initial set of factors.
So in the overall model fit, we're recreating covariances, but what kind? Polychoric versions, yes. So when we're switching estimators, we're not just switching estimators, we're switching models. This is an IFA model where we're estimating loadings, thresholds, residual variances are fixed to 1 for identification, and what the model is trying to recreate is the overall polychoric correlation matrix across the items, not the Pearson correlation matrix. So the target in terms of what it's trying to do is a little different. So this one tells us that we did not adequately recreate the polychoric correlations among the 49 items. This one is the one that tests relative to the 5-factor model. So the fact that it's wildly significant means what? Who wins? Five-factor wins. Yep. Yep. So you can say 1-factor fits worse or 5-factor fits better. Take your pick. This would be 1-factor fits worse based on the order that I did, but that's a semantic distinction. So that means that the 10 correlations are not 1. They're something other than 1. Reasonably good fit for the rest of the stuff here. So here's the higher order factor model. So this is reinforcing the idea of what the right answer is with respect to the structural model. Analysis now, we're comparing back to the 5-factor. This is currently the higher order factor model that we're saving the info for. So it has to be in this order because the 5-factor model has more parameters. It has 10 correlations that we are going to try to recreate with 5 loadings within this analysis. Same process of changing the method of identification. So I'm fixing the first factor loading to 1 in all of these things. What didn't I write in terms of code for the measurement model? I'll ask the same question. What else is there to be estimated besides loadings? What did not I write? What didn't I write? What did not I write? That has to work. It didn't work. What else is it in the measurement model? Thresholds? Yes. How many? All of them? How many items do I have? 49. How many thresholds per item? Up to? There are 5 response choices. So how many thresholds maximum per item? 4. So 49 times 4 I didn't type. So why didn't I have to? Because they're estimated by default. I don't have to request them. When would you want to is when you're turning thresholds into difficulty parameters using model constraint. Then you have to list them all out and label them so that you can do math on them. That would be a tedious process, but possible to do. What about residual variances? Do I need to write about those or no? Not in this model. They're going to be fixed to 1. However, if I did that in a full information solution, it would yell at me. Several of you discovered this. If you ask for residual variances when you're using full information maximum likelihood for IFA models, it's like, no, there are no residual variances for that. So this is uniquely a limited information concept that you would even have something to refer to, but they are fixed to 1 by default, so you don't have to worry about that either. So in terms of all of the degrees of freedom, let's see here. I had that computed somewhere. Where did I do that? Yeah, here's the list. So there's 1,421 possible because note there's a little bit different, it's a little bit different formula. This part, I should put parentheses on here. That part is still the number of variances and covariances of your items. 49 times 4 is the number of proportions that you would have. Essentially, that is the analog of a mean, because this is being treated as a categorical variable. I would need to know the proportion of people in 4 of the 5 categories, and then I know the other one has to be whatever the difference is to get to 1. So the degrees of freedom then start out with that as the number possible. We spent 255 to estimate the model, so that's 49 loadings. 49 times 4 equals 196 thresholds, plus 10 correlations in the 5-factor model. And then it also still counts the residual variances against your degrees of freedom, even though they're fixed to 1. I don't understand why it does that, but that's why I put it in quotes, because that's what the difference has to be. So we get 1,117 degrees of freedom left over. So a lot, point being. All right, and survey says, diff test. So this diff test is comparing the saturated, let the correlations be whatever they want model to the make the correlations only get recreated by the higher order factor. What do we conclude? Who wins? So this diff test is the 5 correlated factors model against the higher order model, now in IFA. Higher order model or 5-factor correlated model? That's what's being compared here. It's the 5 correlated. Let them be whatever they want is better. Yes. Yeah. Essentially, we have a misalignment. The 5 loadings are not adequately predicting the 10 correlations. This is what this is telling me. Despite the fact that the rest of the model fit looks reasonably okay.
So when you're setting up the diff test, does it matter which order you do it, which way it does the calculation?
Yes, it has to be done this way, or it will yell at you. So you have to start with fitting the 5-factor model first and saving it, and then using that saved result in the analysis command when you do the higher order factor model. And I'm saving the results of that for the next comparison as well.
Okay. And if you got that backwards, would it break the diff test, or would it do it backwards?
If I got it backwards, you would get an error message that says something like, HO model is not nested in comparison model. And then you just wouldn't get a diff test. It's something like that. I'm sure someone's seen it. Yeah. I know I do that at least once a week, so someone else has to have done that. It's easy to forget, or just forget which in my code. In the examples that I build for you, what you don't see is the stack of these statements that I have to turn on and off with comments each time I rerun something, and if I forget to turn the right one on, then it's not nested and it yells at me. So yes. Let them be what they want. So even though their overall model fits decently by most of the standards, this fits worse in terms of the structural model, which is what we're concerned with. Standardized loadings, though, all look really good. A little bit higher this time for corrupt relative to the previous solution using CFA. But what's wrong with it? So here is the 5-factor let them be what they want model. It has a similar profile to the other one in terms of pockets of lower correlation for the corrupting one, or the, corrupting especially, it looks like. Here is what the model predicts based on a single higher order factor, and here's the discrepancy matrix. So it's the same terrorizing and corrupting have an additional positive relationship beyond just whatever is in common by the higher order factor. Terrorizing and ignoring have an additional negative relationship beyond what is in common. So those are the two that look to be an issue. This one also, isolating and ignoring, same magnitude in terms of this one. Spurning and corrupting is actually a little bit higher. And why did I bold those ones? Because they were the ones that the modification indices are paying most attention to. So it's not always the largest in absolute value with these models because there's differential weighting that's happening based on how sure it is what those correlations are. So that's the WLS is weighted least squares. The MV part is a weighting process that prioritizes polycorrelations that are better estimated over ones that are less well estimated in terms of adjusting the model fit statistics. So it's concerned with corrupting and terrorizing and ignoring and terrorizing more so than the others, even though the other relationships are just as off if we just look at an absolute discrepancy. So to fix it, add them back in, disturbance covariances by a with statement, and Word apparently has decided that it doesn't want you to see my results. It was doing this yesterday for like no apparent reason. It just decided to garble my text. Oh, now it's okay. Oh, that's very creepy. Let me see if I can replicate it. Okay, it's cooperating for no apparent reason. So did it work? Can I just say alpha 0.01 and call it good? Problem solved. I have too much power. I'm going to change my alpha level so I get the conclusion that I want. No. It's still not consistent with the 10 correlations. There's still some other stuff in there, but this is a point where it's, you know what, I just give up. Yeah, and so did Word, see? What you can't see is the words that say, I'm going to call it done. There. What in the heck?
Oh my god.
It's creeping me out, man. I don't know. Well, it says, I'm going to call it done. That's what it says right here. Here's your write-up. Good luck with that, reviewer two. You know, I joke sometimes that people say things that sound like word salad, but this is the closest that I've actually seen to actual word salad. But the PDFs hopefully have the right version of it. So I don't know why this is not a higher order factor, but I lack the expertise in being mean to children that would allow me to further diagnose this misfit. So how's that? There. All right, questions on any of that? So you feel good about the higher order factors. You can do this. You don't have to do this for this class. The last assignment you have is invariance. So the rest of this is just freebie material for the rest of your lives in terms of assessment. All right. Let me change gears a bit and talk about when stuff breaks and solutions for that. So several of you ended up adding lots of error covariances to your models to make them fit, and then discovered that when you tried to switch over to full information maximum likelihood for your IRT models, that it would not let you have all of those error covariances, so you had to do specific factors instead. So I want to do a little more discussion of that, because that is a more general strategy than adding error covariances that comes in handy in a bunch of different situations. So I am picking up in lecture 8 with slide 13. More true stories. So I used to do this part at the beginning of the semester, but I decided to move it towards the end because now we have the skills to actually try to fix things. So latent variable measurement models can represent multiple underlying constructs at the same time, whether it's CFA, IFA, IRT, or what have you, but only to the extent that your items in the design can distinguish them. So in general, when you're making a new scale and writing items, you want to have each item cover a single thing with an explicitly defined referent. Like if you're asking, you know, when I get the surveys from having to go to the doctor's office, they're like, this is your care provider. Answer these questions about this person, as opposed to think about the last time you went to a doctor, right? The referent has to be clear if you're answering questions about something. Response options have to be applicable to everyone. And ideally, things would be not too narrow, but not too broad at the same time. And this is all easier said than done. So do not confound intentionally stem, valence, or construct. Valence meaning whether it's worded positively or negatively. And I will say this, just because someone made a scale and fit a CFA model to it 30 years ago and it worked once, you are not beholden to use exactly what they found. In every other aspect of science, we continually improve things, right? We change designs, we refine techniques, we improve our methodology or our measurement, you can do that for scales too. So if someone wrote a scale that has problems, you can fix it. You can make a new version and try to publish it, and then hopefully prevent other people from having these same problems. So let me give you some examples from previous work that I've been involved with. Why might some of these items have problems? How important is it to you on a scale of 1 to 5 that your family members have good relationships with extended family, e.g. grandparents, in-laws, etc.? Why might this item be problematic? Zoomer say covers too many relationships. Yeah, I would say that by giving these parentheticals, you've created an awkward situation. It's like, well, I want Hugh to have a good relationship with my parents, right, grandparents, but maybe not my in-laws, of course, right? These are two different things potentially. Here's one that's a little bit less obvious, but this was a real item from a real scale that caused real problems. My family is physically healthy. How important is it to you on a scale of 1 to 5?
Who's gonna answer, like, no, I don't care at all if my family's physically
Exactly.
healthy.
What
Forget
kind
it.
of monster is going to be like, it's fine? They don't need to be healthy. No. And even if you felt that way, you're probably smart enough not to write it down on a questionnaire, because then once again, social services is coming to your house. So no one is going to say no to this. But what they could say no to are things that help you become more healthy. Maybe how important is it that my son eats vegetables beyond baby carrots? How important is it that he gets, good rest? How important is it that he sees a doctor once a year, even if he's not sick, which really confused him when he had to do that this year. Like, but I'm not sick. Why am I going to the doctor? It's called an annual checkup, buddy. You have to go. Oh, okay. Those are the kinds of things that people might disagree with. So yeah, this item had no variance. It was a constant. And do you know how well constants work in models? They don't. You can't have covariance if you don't have variance. Here's another one from a different scale. What is the quality of the relationship that you have with your children? Charlotte, how is your relationship with your children?
Well, I don't have children.
Maybe they're latent children. They're unobserved.
I don't think anybody would like volunteer with information that they don't have good relationships with their
Yeah,
kids.
so you don't know how to answer this question because you don't have children yet, I think, if I remember correctly. But what if you have more than one kid and you get along with one of them and not the other? Now how do I answer? Yeah, which child, right?
You're not allowed to pick favorites.
Yeah, you're not allowed to tell them that you have favorites either. That's definitely not cool. That's part of the terrorizing factor, I think, or spurning or something. But yeah, so this is problematic because of children plural, I would aver, but then there's no response for people that this is not applicable to. So you could leave it blank. You could guess, like, if I had children, then maybe it would be important that I have a good relation. Like, no, don't make people do that. Just give them a response option for doesn't apply to me or don't want to answer or something along those lines so that you can get decent data. Here's another one. To what extent did others make it difficult for you to engage in various activities before your imprisonment? Yeah, this is from a sociology, criminology background. Hi to my sociology people. They're doing this. Like,
Was this administered strictly to people who had?
this was administered in a prison sample.
Okay.
Yes, it was. Does anyone have any idea what the hell this question is asking?
It's just ambiguous.
Who are others? To what extent did others make it difficult for you to engage in activities?
Various.
I'm going to go with never because I have no idea what this means. No, these are actual questions. So clear referent maybe is a problem on this one, I would argue. Here's another one. I see a lot of this. I rarely feel sad. Strongly disagree, disagree, agree, or strongly agree.
The wording of that question is confusing.
I could say I strongly disagree because I rarely feel sad, or I could strongly disagree because I always feel sad and it's not rare. Like there's two different things you could be responding to, and the rarely causes problems.
Yeah, is that trying to get at, I feel happy?
I rarely feel sad, is that the same thing as feeling happy? I'm not a social psychologist or a health psychologist, but I don't know. I don't know what they're going for here, but there rarely causes problems. That's what I know. Here is a scale that I wish someone would fix already. Okay, free research ideas. This thing is called the DIRS. Difficulties in emotional regulation. I've had several students over the years analyze this scale, and the pink one always falls apart. So this one is composed of, it's called lack of emotional awareness, and the items are all positively worded. So they have to reverse code the entire scale to get it to be lack of emotional awareness. This one then is different because there's only reverse coded items on one or two places for the other scales, and this is all that way. So if lack of emotional awareness is less related to other things, is it because of that particular construct, or is it because all those items are reverse coded and it's a confound? Here's another one. The very first items on the scale, lack of emotional clarity, says I am, I have, I know, I am. Then we get into I pay attention, I am attentive, I care, I experience. And then all of a sudden, after those items, it switches to when I'm upset, comma, I do these things. How you behave on a general level is not the same thing as how you would behave when I'm upset. And so if you're already answering questions about that are perceived as this is how I generally feel, and then all of a sudden it switches to when I'm upset, that's going to be two different things just because of that. But this is easily fixable. You could add when I'm upset to all the initial items, or you could take away from all the other ones and make it consistent. And there are ways to avoid having to do reverse coding that have become more common, and so I wanted to talk about those two, but that's not this slide. Here's another project where someone fixed it. This is a former student of mine. I'm third author on this. This is schizotypy, I think. It's like lower level tendency towards conspiracy theories, and people are out to get you kinds of like paranoia types of things. And they had subscales where some of the wording was, do you feel like this? Or I do this. And it turned out that this you versus I distinction caused a bunch of problems. So he reworded it. He fixed all the items to start with I, and it led to better psychometrics across several different replications of this. So this is now a new version of this scale because of the changes in the wording. But the factor structure is much cleaner. Here's how you can fix reverse coding by not doing it at all. I think this is really cool. This is called an expanded format. It came out within the last 6 or 7 years. There's an article that's using it that demonstrates how it works here. That's on your reading list this semester. Here's the link. So rather than having to reverse code things, you can write it out in a way that allows the full range of the choices. So for instance, I feel I have a number of good qualities, or all in all, I'm inclined to feel that I'm a failure. Those are clearly going in different directions. One of them would have to be reverse coded to match the other's intent. Or you could write them this way. I feel I have almost no good qualities. I feel I have a great many good qualities. Now you can get everywhere from the low end to the positive end all at once. So this is longer, but I would argue it probably makes more sense because the second item here especially, I feel I am very much a failure. That's about as low as you can get versus very much a success. So it spans the whole thing. And in their study, they manipulated basically they randomly assigned people to groups, gave them different versions of these items, and compared the factor structures across it. And in the ones that had to be reverse coded, almost always the solution came out to be multiple factors. In the versions that had these expanded formats, that was a one factor model as intended. So this is what I would recommend. Don't do reverse coding. Build in the item choices the way that you wanted to have it. And keep in mind that everything you've ever learned about experimental design, random assignment to things, manipulation, Charlotte's smiling, it's like, yeah, you can do that here. So hi T, I'm gonna give T a shout out. Her dissertation is doing this to a scale where she's randomly assigned people into the expanded format versus the traditional format, and she's gonna see, she's gonna examine measurement and variance and see which one works better. So stay tuned for the exciting conclusion of that example probably next time I teach the class. We'll keep building it in here. So this is what I would do. All right, 142. I think that is a good place for us to stop. So does this give you any ideas about interesting psychometric research that you could try? I think it could. I will tell you that if you look at my Google Scholar page, almost all of my most highly cited things are measurement papers. I did a factor structure, and that means everyone else who's going to use my factor structure has to cite my paper, no matter what the paper's about, right, if they use this measure. So yeah, measurement papers can become very highly cited because of, for commonly used measures. So I would encourage you to think along those lines as additional value added to the projects you're doing. If you had to do psychometric work to get to the point where you could use your scale, that effort is publishable all by itself. And I can help. So, all right, 143. Questions or comments before we call it a day? No Zoomers? No rumors? Okay, then how about you go home 2 whole minutes early? You are welcome. Thanks for being here. Let me know if you need anything, and you can work on your next formative assessment in the meantime.